Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniela Tran here, and today we are going to work on section 6-3 from the IFM Practice problems. So let's look at problem 1. Judy decided to take a short position in 20 contracts of S&P 500 futures. Its contract is for the delivery of 250 units of the index at a price of $1,500 per unit, exactly 1 month from now. The initial margin is 5% of the notional value, and the maintenance margin is 90% of the initial margin. Judy earns a continuously compounded risk-free interest rate of 4% on her margin balance. The position is marked to the market on a daily basis. On the day of the first marking to market, the value of the index dropped to $14.98. On the second day of the marking to the market, the value of the index is X. Judy is not required to add anything to the margin account. Calculate the logic possible value of X. So this problem is about the margin balance and the maintenance margin. And we consider the beginning, then the first day and the second day of the marking to market. And in order to set up the iteration to make a change to calculate the margin balance from time 0 to time 2, we have to first determine the notional value in order to determine the maintenance margin. Here, the notional value is the products between 20, 250 and 1500 because we have totally 20 contracts. Each contract has 250 units, and each units the price is 1500. So the notional value here is $7.5 million. Now it is given that the initial margin is 5% of the notional value, so we take the notional value times 5%. We got 375,000. This is the initial margin, and I notated by MB0, mean the margin balance at time 0. And it's also said that the maintenance margin is 90% of the initial margin. So we got the maintenance margin is 90% of 375,000, which is 337,500. And now we can set up the iteration to calculate the margin balance on the first day and on the second day. The first day, we got MB1 representing the margin balance on the first day. Remember, in a year, we got 365 days. So T here is 1 over 365 because we consider 1 day. So the margin balance at time 1 is equal to the margin balance at time 0 times e to the 0.04 over 1 over 365 plus 20, which is the number of contract, times 250, which is the number of units in its contract, time with the differences between the initial price and the price on the first day. So we got the margin balance at the end of the first day is $385,041. And similar, apply the iteration. Again, we got the margin balance on the second day is 385,041.098 1 times e to the 0.04 over 365 plus 20 times 250 times 1498 minus x. However, it said that Judy is not required to add anything to the margin account, which means MB2 should be equal to the maintenance margin 337,500. And from here we have an equation of x. So solve for x. We got x is $1,507.51. Problem 2. You enter into a 10 contracts of S&P 500 future, which is trading at $2,100. Its contract consists of 250 units of the index. The initial margin is 10% of the notional value, and the maintenance margin is 80% of the initial margin. The continuously compounded risk-free interest rate of 5% was a graded future price that will result in the margin call one day from today. Actually, there are two ways to solve this problem. You can either apply the method that we use in problem 1, but for problem 2, I want to introduce another way to solve this problem. Remember, here we got 10 contracts. Each contract had 250 units, and this factor applies for all the steps. So basically, in order to simplify the problems, we can ignore the number of units. So let's look at day 0. The future price is 2100 and the initial margin is 10% of the notional value. The notional value is just the 2100 times with the number of units in total of the 10 contracts. Now we ignore the 10 contract with 215 units because that's a common factor for all the steps. So we got the initial margin here 210, and the maintenance margin is 80% of 210, which is 168. Now day 1, the future price is X, and we apply the formula. We got the balance. The maintenance balance is 210. Here is the initial balance, time with the continuous rate, e to the 0.05 over 365 plus X minus 2100, and we got 168. This give X is 257.97. Here this is 0.05 over 365. I make a mistake. It should be 0.05 over 365 because one day is 1 over 365 years. Problem 3. Sonny Jim entered into a long position of 12 contracts of S&P 500 futures. His brokerage account requires him to set up an initial margin of 15% of the notional amount of his position. Further, he has a maintenance margin requirement equal to 80% of the initial margin balance. Margin balance is settled on a weekly basis, and the current continuously compounded risk-free interest rate is 6%. The S&P 500 index futures prices are: the current price is 24.27. At the end of the first week is 23.65. At the end of the second week is 23.85. Determine the margin balance at the end of the second week. Note that S&P 500 future contracts, the contract units is fixed at 250. So, again, for problem 3, there are two ways to solve this problem. You can either apply the method in the first problem or the method in the second problem. Here I'm going to use the first problem method. First, the notional value. We take the number of contract 12 times the number of units in each contract, which is 250, times the current price of each unit. So we got 7.2 million, around 7.3 million. And now the initial balance is 15% of the notional value. So we got 1,092,150. And then to apply the iteration, we got the margin balance at the end of the first year. The first week is 109 to 150 times e to the 0.06 over 52. Remember, 1 week is 1 over 52 of the year because a year has 52 weeks. Then plus 12 times 250 times 2365 minus 2427, and we got 907,410.9. And then similar, we got MB2 is the margin balance at the end of the second week is 968,457.52. Problem 4, just do it similarly. Sonny Jim entered into a long position of 12 S&P 500 future contract. His brokerage account requires him to set up an initial margin of 15% of the notional value of his position. Further, he has a maintenance margin requirement equal to 80% of the initial margin balance. Margin balance are settled on a weekly basis, and the current continuously compounded risk-free interest rate is 6%. The S&P 500 index future prices are current 24, 27, and at the end of the first week X. Determine the maximum value X that will result in a margin call at the end of the first week. So here I'm going to use the second method. At the beginning, the margin balance is, here again, I don't want to care about the number of contracts and the number of units because that's a common factor for all the steps. And when we solve for X, if the question asks to solve for the price, then we can ignore the common factor. But if the question asks for the balance, then we shouldn't ignore the factor. Now at the beginning, the margin balance here 24.27, the current price, times with 15%. Because I said the initial margin is 15% of the notional amount, and the maintenance margin is 80% of that. So we got 291.24 is the maintenance margin. Then at the end of the first week, we got the margin balance MB1 is equal to 364.05 e to the 0.06 over 52 plus X minus 2427. Because 364.05 is the initial balance. T is 1 over 52 because a year has 52 weeks, so a week is 1 over 52 year. And we got a difference between the price at the end of the first week and the initial price. And since we want to determine the value X that would result in the margin call at the end of the first week, so we have to set MB1 is equal to the maintenance margin, which is 291.24. So X here is 23.53. So the answer is 23.53. Alright, so that's it for today. Thanks so much for watching. I hope you guys enjoyed my video, and I'll see you in the next video. Bye bye.